Hello, everyone. This is Elisa Baum. I'm GridGain Systems Director of Product Marketing. We'll begin in just a moment, but I need to conduct some housekeeping. Could you please use the hand icon in the GoToWebinar control panel to let me know if you can hear me okay? So let me take a look. Can everyone hear me okay? Yes, I see hands. Okay, thank you. Next, during this presentation, you will be on mute, but should you have any questions for the presenter, please go ahead and enter them in the questions field in the GoToWebinar control panel. And at the end of the presentation, we'll take time to answer as many questions in the time that we have left. I'll also make sure that Akmal, our presenter, has a copy of all your questions in case we don't get to yours. Also, please note that about 24 hours after, up to 24 hours, I'll be processing the recording, and I will send everybody a link to both the recording and the slides. So you'll have those in your email within the next 24 hours. So with that said, thank you so much for joining us for today's webinar, Ignite the Fire in Your SQL App. It's being presented by GridGain Technical Evangelist, Akmal Chaudhry. And with that said, I turn the floor over to you, Akmal.
Thank you very much, Alicia, and thank you very much again for everyone that's joined. GridGain appreciates that you have a choice, and your time is valuable, so we are really grateful that you've had the opportunity to join us today, and hopefully this will be an informative and useful session for you. So what we plan to do is to cover a little bit on SQL predominantly, but we'll say something about the architecture of Apache Ignite, and we'll have a couple of demos as well. And I hope the screen resolution and the fonts will be reasonably good for you to be able to see the demos. I'll do my best to blow up the windows as I can to make them larger. Hopefully you'll be able to get reasonable font sizes. We'll try our best. And again, if there are any problems, please leave some messages in the chat box, and we'll be able to pick those up. And if you're having difficulty seeing stuff, then I'll be... Okay, great. So let me just
interrupt you. I think you fell out of the presentation mode for your slide deck. So
okay.
You need to go back to the slideshow. Sorry to interrupt.
There we go. Is that okay?
That's beautiful. Thank you.
Great. Thank you very much. And there we go. So, so Apache Ignite. So in-memory performance, durability of disk. And we'll discuss what we mean by the durability of disk through the demos that we present and the discussions a little bit later on. Okay. So as Alicia mentioned, so the title, Ignite the Fire in Your SQL app. So a strong focus on SQL today, and looking at various ways that we can use this, using with a third-party database system, for example, and also using Ignite's native persistence, which we'll talk about more a little bit later on. Okay, so in terms of agenda then, so it's fairly simple and straightforward. And so we'll begin a little bit of discussion on the architecture, high-level view of Apache Ignite and some of the capabilities that GridGain provides. For example, these are enterprise-level features. We'll say something about the connectivity, a little bit on the data definition language, DDL, data manipulation language, DML, and then we'll go into a couple of options there and how you can access data either through some external data source, such as a relational database system, or could be HDFS or a NoSQL database system, and also using Ignite's own native sort of persistence capabilities, where we can read and write data, and it can store it beyond the lifetime of the process that created it. And subsequently, if we take our cluster down, for example, and then bring it up later, we can read that data back in again. So it's not just keeping everything in memory. Okay, so this is a nice kind of high-level chart which really captures very succinctly what Apache Ignite and GridGain is all about. So if we look mostly on the left-hand side there, all that is in black and red, these are the Apache Ignite features. So you can see that memory-centric storage is fairly central to all of this. And historically, if you look at the background where Ignite came from as an in-memory data grid, I mean, this really, it shouldn't come as a surprise. It's a key value store, and you know, the capabilities as a data grid, as a key value store, very robust and reliable features. You know, this is the roots of the technology where it started. But equally, over time, and particularly last year, for example, a lot of strong SQL capabilities added, ANSI SQL 99 compliance. Transactions have been added as well. So now you're getting to see this product really evolving to the state where you can treat it as a distributed database system. And that's quite, you know, capable. There aren't too many of these products on the market. I think there's a few that you may have heard of, such as the technology that Google have developed, for example, based on Spanner. There are some research papers around that. But building this type of distributed technology with SQL support, very few products out there on the market. Again, historically, looking at some of the other sort of capabilities, the compute grid, services, streaming capabilities as well, so various plugins and adapters for a number of popular technologies such as Flink, for example, or Spark, and machine learning as well. So this has been added, and there will be some upcoming webinars that we'll be organizing, and blog posts that will be in the pipeline over the next month or two to discuss that in more detail. At a high level, then, we look at the various vertical markets, and if you look at the examples on the Apache website, so everything from financial services, telecommunications, e-commerce, healthcare. You know, I wrote a couple of blog posts late last year on covering sort of the use of Ignite within the healthcare space, and IoT as well. So all of these domains really very well covered. There are lots of examples out there of organizations using this technology, and these examples can be found on the Apache website. Drilling down to the bottom, then, we can see sort of two things there. So on the left-hand side, at the bottom, we see the Ignite native persistence, which we'll talk about towards the end of the presentation. And then the third-party persistence, kind of in the middle there, RDVMS, it says HDFS or NoSQL. Today, we'll look at how we can use MySQL and the data that's stored within MySQL and be able to read and write that and be able to access that from a cache. Okay, so this is the step-by-step process that we'll walk through. However, as it says there, it could be some other data source as well. So if you're working with popular NoSQL products such as MongoDB or Cassandra or technologies like that, you know, you can integrate those as well. On the right-hand side, you will see a couple of these blue bars. These are specifically enterprise features that GridGain offers on top of Apache Ignite. So it's built on Apache Ignite, but there are some enterprise features that GridGain provides, things like snapshots and recovery, monitoring and management, security and auditing, and data center replication. So these are sort of paid for features. So if you're working in an enterprise environment and you need these capabilities, then you would discuss that with us at GridGain, see how we can help you and assist you with these features. Okay, so let's move on and look at some of the SQL capabilities then. Okay, so what the Apache Ignite has become is really a distributed SQL database. And again, if we look at this graphic, there's kind of three sort of separate parts there. Towards the bottom, we can see the Apache Ignite cluster. Okay, so this can consist of a number of different server nodes that we can use to form our cluster. Now, it mentions durable memory here. Okay, so durable memory, the ability to store state, data beyond the lifetime of the process that created it. Storing both data and indexes on disk and in RAM. Okay, so all of the data are stored on disk. Some of the data may be cached in this instance if we're using this persistence capability. And then on top of that, we have a number of capabilities as well in terms of how we access the data. So there is top-level support for Java, .NET, C++. And then if you're working with other languages such as Python and Ruby and so on, then we've got JDBC and ODBC connectors to be able to do that. And of course, you can use SQL directly as well and embed that within your code, or you can use it from a web console, which I'll show you in a few moments' time. And of course, full SQL support, full ANSI 99, I mentioned this. Okay, so DDL, DML support. You can do all the kind of things that you do with SQL in terms of selecting data, doing joins, updates, merging, creating tables, deleting tables, changing tables, the alter statement, and so on. So great cross-platform capability. And again, there's been some articles published last year, for example, if you search on DZone and search the GridGain website, showing how we can use these multiple platforms. So we can, for example, create objects in Java, be able to store these, key value store, and then be able to read these using .NET, for example, and be able to work with these, and again, be able to share these with the Java. The key benefit here is that within organizations, you may have multiple teams working with different frameworks, different programming languages, and here you can use Ignite as a way to be able to share that data, that state, that information across these different frameworks and languages. So very capable and very useful feature in the modern world today. Other things, so BI tools. Now, as you know, SQL is a fairly sort of widely used technology within database systems, and it's kind of intergalactic data speak. So whether you're working with business intelligence tools to be able to query your database, draw these kind of dashboards, if you like, to get some information out, then this is the standard that's used. And of course, plugins for other tools as well that work with SQL or have JDBC or ODBC support. So range of capabilities there, and I think expect to see more interesting developments coming along as far as multiple language support is concerned as well. So there's a great deal of discussion on this on the dev list, and I encourage you to join and to participate in that. Okay, so in terms of the connectivity then, very, very simple and straightforward. And so we've got a little bit of JDBC sort of code and some examples there on the right-hand side, how to actually register the JDBC driver and then how to open a connection. This is using the thin driver. And again, I'll show you an example of this very, very shortly. So we've talked about high level and sort of full support for these three main languages, so Java, .NET, and C++. But equally, there's a REST API as well, and we don't cover that specifically today. But again, there's plenty of information in the README IO website, and if you go through the Apache website as well, in terms of the documentation, you'll be able to pick up all this information as you require it. Okay, so data definition language, as I mentioned before. So here we've got an example on the right-hand side, create table, and then as you can see, all these standard types in terms of integer, character are supported. We can create a primary key. Some slight extensions there that you can see at the end there with this sort of with statement. So template equals partition, backup equals 1, affinity key equals country code. Okay, so this is adding some small extensions there because we can do some interesting things then. So one useful feature that we have within Apache Ignite is this idea of co-locating data. So this is useful in a distributed environment because what you want to do is to avoid a lot of movement of data. If you can co-locate data somehow on a particular cluster node, then you can push the queries to that node, be able to execute them locally and get a response back, rather than having to shift a lot of data around your cluster, which is something that you really don't want to do. And again, we'll look at some graphical examples of that very, very shortly. So full support there, create, drop table, create drop indexes, alter table. Again, if you want to modify your schema, you can do that. And again, we'll look at how some of these capabilities are supported through the demos we'll do shortly. Now, in the bottom left-hand there, you can see a URL. This is a link directly to the readme.io site for the Apache Ignite documentation, where you can get a lot of sort of more examples and how the syntax is used as regarding the data definition language. Similarly here for the DML, again, there is a link to the directly to the readme.io site. And as I said before, and we mentioned this a few times already, the ANSI 99 specification insert, update, delete. We can do joins, subqueries. And if we look at the example there on the right-hand side, we can see that there's actually quite a lot that's going on within that SQL statement. So we're doing a select, and we're also doing a join. We're specifying a group by and an order by, and also a limit clause there. So there's a fair bit that's actually going on there that you can see. This is, if you're familiar with SQL, I mean, all of this kind of syntax and the structure of this query should be very, very familiar to you. Okay, so I mentioned this notion of joins and co-location just a few moments ago. So this is kind of a nice example that demonstrates how this could work in practice. So here we have happen to have two different countries, Canada and India, and we are interested in co-locating cities in those countries together with the country data itself. And so in this particular instance, we've got a two-node cluster. And we've got one country on the first node and all its cities associated with it on that node. And in the second node, we've got the second country and a couple of cities that are located there. And this is kind of useful because, again, if we're running queries across these cities, the thing that we want to avoid is a lot of data movement. In this case, we've got a very simple cluster of two nodes, but imagine if we had hundreds of nodes or thousands of nodes, if there was a lot of data movement that was required in order to run one of these SQL queries, that could really tie down a lot of resources on the cluster unnecessarily. So the query itself, if we look at the structure of the SQL, and that's fairly sort of standard. Okay, so we're looking at a country table. Okay, but we happen to have co-located the cities with that. And in this particular instance, you can see that it's, again, all fairly standard SQL, nothing special here. We've done that co-location already. Now, moving on to the next example where there's no co-location, you can see that the query itself is exactly the same. That hasn't changed. But in terms of where the data are distributed, it's slightly problematic now because we haven't done the co-location properly and data are scattered across these two nodes. So in order to be able to answer that query, there may be some data movement. Now, in this small kind of cluster of two nodes, perhaps that's not very significant. But again, think of the scenario where we've got a much larger cluster consisting of tens, hundreds, possibly thousands of nodes. And we're trying to run these type of queries where data are scattered all across the cluster, where we have to do sort of movement and joins. This could, again, tie down considerable resources. Now, the thing is that how to know when this is useful? Well, this is part of the design of your cluster, part of the architecture, part of understanding the type of queries that you're going to run, how you're going to utilize the resources to efficiently in your cluster. Okay, so this is all part of the design process. But the fact is that Ignite can help you in this instance in terms of doing this type of co-location if you've specified it. And then, again, we can envisage scenarios where other scenarios where this might be useful, and the classic one that I tend to use is the one that if we think back in time a few years ago, we know that this hurricane, for example, hit New York. Now, if we had say an Apache Ignite cluster and we were storing information about people living in particular cities, and we were able to co-locate that information of the actual people in the city itself on a particular node, and we want to send a weather warning, we know exactly where the data are resident, and we can send that weather warning out without having to shift around a lot of data across our cluster. Okay, so there's a kind of a practical example of how this might work and could be very useful for us. Okay, so let's kind of move on a little bit then and have a look at how some of this capability and how we can work with some types of third-party storage. Now, one of the design kind of principles and one of the ideas behind Ignite is this kind of no rip and replace. Okay, so if you've invested some considerable sum of time, effort, money with an existing database system, for example, you might be working with MySQL or Postgres, for example, and these serve a very useful business purpose for you, you can keep that investment. And Ignite can then help you, and it can integrate with these and can do so quite effectively. So what we can do is then kind of turbocharge what we have already in terms of the data that we're storing. So in this case, we look at the bullet points then. So the first point, I think, is a significant one. So slide Ignite in between the database system and applications, because it can give us a performance boost. It can do the parallelism. It can provide, being able to cache that data. We can run things at memory speeds. And the other thing to note here is if we look at the graphic on the right-hand side, we can do both read-through and write-through. And I'll show you some examples of that very, very shortly. Second bullet point there on the left-hand side, no rip and replace performance boost, okay? Because we are taking advantage of the investment that we've already got, but using Ignite to help us with additional capabilities and give us that sort of boost in performance that in-memory will help us with. So keep data both in memory and database systems, scale to thousands of nodes, right? So one of the key features of Ignite is that being an in-memory data grid, and that's coming historically again, but there's other capabilities that have been added, but where the roots of this technology have come from, if we utilize it just for those capabilities, then it gives us kind of tremendous performance benefits as well, in terms of caching data, in terms of parallelism, utilizing the resources of the cluster, running things at memory speed. All of these have tremendous benefits. And today, particularly for a lot of business decisions where timeliness is very important, business decisions need insights very, very fast. This could be very, very important to you. Again, next bullet point, automatic read-through and write-through. I'll show you this very shortly in the demo that I'll do with MySQL to see how this works. And again, ANSI 99 SQL over in-memory data sets. I'll show you again an example of how we can utilize this very shortly. So this can be done directly through code within the application that you've written, or there is a web console as well, which allows you to run some queries and be able to interrogate the database and then be able to get some results back. And again, we've got some examples to demo this as well. So one of the things that we have is a very useful tool is this Apache Ignite web console. And this simply is console.gridgain.com. This is the website that you would need to. Now, I'm going to run this in the demo that I show you very shortly directly from the GridGain website. However, normally what you would tend to do is to install this and have this behind your firewall so that you run this internally in your own systems. And be protected from the outside world. I mean, that's the standard process. For the purpose of the demo here, because it's a very sort of simple demo, and I happen to be a GridGain employee, I'm going to use this on the actual sort of GridGain website, and we'll look at that and see how that works in just a moment. Okay, so let me exit from here, okay, and just minimize this for the moment. And so the first thing I want to show you, and again, I'll do my best to blow some of these windows up and see if we can't make them a bit bigger. So let's just try and see what we can do here. Hopefully that's a little bit larger for you and you can see that. So all I've done is I've got a standard distribution of MySQL. I've installed it here on my Mac. There is an example kind of employee database that you can also download from the MySQL website. I've just imported that data in, and it comes with a series of tables. So it's not very, very large, but neither is it small. It's kind of reasonable size to be able to do some testing, be able to run some queries. And here you can see, excuse me, I've just run a quick query here. Select star from employees, limit 5. So just return 5 employees from this particular employees table. Okay, so this is the first step. Okay, so we'll come back to this in a short while, because we're going to do some data updates and modifications as well, and we'll be able to run this query again. And just to show you that I'm not, haven't got any sort of thing up my sleeve, let me just run that again just to show you that that is actually the data that we currently have. Okay. All right, so now here is the console that I mentioned just a few moments ago. Okay, so this is console.gridgain.com, and I've registered, as you can see in the top right hand corner here. It says Akmal Chowdhury, profile, getting started, log out. So I'm logged in currently to this. And we've got a number of options available on the left-hand side. You can see clusters, model, caches, IGFS, GridGain, summary. And we're going to use some of these features today. So the first thing we want to do then is we'll go here where it says configure Ignite clusters, and we'll do add cluster. Okay, and let me just scroll down a little bit. Again, hopefully that's reasonably visible to you. And it's prompting me now for a name for this cluster that I want to add. So I'll just put something simple in here like my Ignite cluster. And all we need to do then is just go up here and then just do save. Okay, so that's done. That's saved for us. Okay, next thing we need to do then is to really import some data, schema information from the database. Excuse me. And if we click here where it says import from database, it will tell us very helpfully that in order to do this, what we need to do is actually download something called the Ignite Web Agent. And we need to set this up and have it running in order for that connection between the console and the MySQL database to take place. So I can click on this. Okay, so download agent, and we'll have a look at that. I actually have it installed locally, but let me just show you that, again, everything is as it should be. So we can open this, and you'll get this zip file. So at the moment, today, as of this presentation, it happens to be version 232. Again, this is something that's continuously developed. And so from time to time, you need to keep this up to date. Otherwise, things don't work because there have been some changes. So it's important to ensure that you get the correct version. All right, so if we just unzip this and have a look inside. So there's a couple of folders there. One of these says JDBC drivers. Okay, so this is where we would place a JDBC driver. And I'll show you what I have set up myself in just a moment, where I've actually downloaded the JDBC driver from the MySQL website and placed it within this folder. The rest is fine. There's nothing else that we need in order to utilize this. So we can just go back here and close this. Okay, and if we go back here now, as I mentioned before, so I've actually got this folder already set up and unpacked on my Mac. And if I show you the folder here, let me just try and again blow this up and see. You can see that. Okay, so in this case, I happen to have the MySQL connector already copied within this particular folder. As I mentioned, the JDBC drivers, and we can just start this. Okay, get that going. All right, now a couple of things to notice here. So you'll see that it's successfully connected to console.gridgain.com. That's good. Connection established. That's good. Authentication success. That's good. And then the last statement here, it tells us at the moment that it's failed to connect to a cluster. We don't have a cluster running at the moment, but that's okay. We'll take care of that very shortly. But other than that, everything looks healthy and it looks good. Now, when they do update this web agent, you may try to run this and it'll give you an error because it's detected that there's a newer version available, and you'll need to download that and install that and use that. Okay, but that's helpful to keep things in sync between the different versions of the software that are being used. Okay, so let's go back. Okay, now, right now you'll notice that very helpfully it's kind of filled this information in for me. Well, I cheated there slightly, okay, so which I apologize, because I did this before. It just so happens it's picked up the information that I previously entered. But if I look at this option here in terms of the jar file, there's only one option because this is the only one that's available that was copied to that particular JDBC folder that I mentioned a bit earlier. There's the JDBC driver name, and here it's just localhost port 3306 / employees. Okay, so this is the database we're working with. Now on MySQL, my MySQL installation, the user happens to be root, and password also happens to be root. So I'll just put that in like this, and again, we'll just click next. Okay, now here it gives us some information as to what it's been able to pick up then. So import domain models from database, that's fine. So employees database is what we're interested in. Let's do next. And here we can see, again, very helpfully, so it's given us the schema name, the table names, and then what caches it's going to create in red there on the right-hand side. I'll take all the defaults here. I won't change anything. That's fine. And then we'll just do next. And again, here, all of these things, it will generate some POJO classes for us. There'll be some XML configuration files as well. But again, all the defaults are fine for this particular demo, so I won't change anything. And again, I'll just do save here. There we go. Okay, so if we scroll down and then have a look at this, so we can get a little bit of information about what it's actually done. So it's actually done quite a lot for us, and you can see on the right-hand side in terms of the XML code that it's generated. There's actually quite a lot, and then there's more that we'll look at very shortly. All right, and what we can do then is if we switch then, so this is the model, and if we look at the caches, okay, no, I don't want to save password, that's fine. And then we can have a look at the caches as well, and let's have a look at this one, the employee cache. And if we scroll down a little bit, again, you can see a lot of these things have been filled in for us, but there are other options that we might want to change, for example, memory or queries and indexing. For example, here I might change the history size to 50, for example. It's fine. And again, notice how the property value here on the right-hand side has popped up. Okay. And what we'll do then is just save this. Okay, so that's all done. Now, the next thing to do then is once we are happy with all of the changes that we've made, and maybe we want to customize this somehow, but for our purposes again, and time is always a factor. I've only changed one small thing there, but the rest I think are fine for demo purposes. We can go to summary. And then it helpfully gives us quite a lot of information here. Now, if you look at the scroll bar on the right here, you can see that it's actually very, very small, which shows us that it's actually generated a rather large amount of information for us automatically. And that's very helpful to us. And again, looking at the Java code as well. Okay, so it's done all of this for us. Okay, so let me go back here. And what we'd like to do then is to actually download this project. Okay, so we can just click upon this, download project, and again, give that a moment or two. It's already done that very quickly. So again, go back to the downloads folder. And if we just open this zip file up and have a look inside, we can see that we've got a pom.xml. There's a JDBC drivers folder, source folder, and so on. And all I would need to do then is just import that into my IDE, which I actually have running here. Okay, so I've got IntelliJ up and running, and this is the same project. Okay, so looking at the structure, we can see there's a number of Java files here, and there's a couple of things that we need to take care of in order to use this correctly. So one of these here we have is secret.properties. Okay, So we need to put in a little bit of information here in terms of, again, where we are running this, what port we are running on, and what is it that we are trying to access. So this is for the JDBC URL, and again, for authentication, the username and the password. So I've just modified those previously already and then just saved that information. So that's absolutely fine. Okay, so the next thing is that, again, very helpfully, the code that's been generated actually allows us to start up a node, and we'll do that directly from this IDE. So let's do that. There we go. And hopefully you'll be, I appreciate the font may be a little bit small, but it's up and running. And if we look at the bottom here, it just says topology snapshot, version equals 1, servers equals 1. That's fine. And let me just run another one. So we've got a cluster of 2 nodes. There we go. So now if we look at this, servers equals 2. That's fine. Switching back to the console here, if we go to the monitoring link at the top and then select dashboard, we can get some useful information about what's actually going on here. Okay, so it tells us in detail that it's picked up this particular cluster that's now running. So helpfully, there's CPU, heap usage, cache latency, cache throughput metrics, and so on. And if we scroll down here, what we can see is that it's actually picked up the fact that we've got one node and another node, and both of these are acting as servers at the moment. And this is for this my Ignite cluster. If we scroll down a little bit further, we can see that there are, in fact, 6 caches here as well. Okay, so these match the tables that we have within that particular database. And again, all of these have been created for us. At the moment, you can see there's nothing there. All of these values are 0. We've got no data in there at all. And we're going to take care of that in just a moment. Okay, so switch back to the IDE. And again, one of the pieces of code that's auto-generated for us is this thing here, load caches. So if we double-click on this and have a look, okay, so the code here, if we run this, this will fill in the caches for us. So it will do, if we recall that graphic we saw in the PowerPoint slides about read-through and write-through. So what this will do then is the read-through part. It will take the data from MySQL and load it into the Ignite cache. Okay, so let's run this. There we go. And then again, I'll try and make this a little bit larger if I can. Again, apologies for the font size. Alicia and I were discussing this a little bit earlier, and we were trying to see what we could do to fix this problem. Not an easy issue to fix, so so my apologies for that. But hopefully, you'll get the gist of this. Now, it'll take a few moments for this to run. Okay, so it's saying loading caches, okay, at the bottom here. So it's doing a little bit of work for us. And again, if we switch back and have a look now at this, which we were just looking at a few moments ago, already you can see that the numbers here are increasing. So these caches are kind of filling up. And it takes a few moments, I think, before all of them are done. So here, again, you can see these numbers increasing. So none, I think the first 4 certainly have data. The last 2 of these still at the moment set to 0, but it'll get to those in a moment as the program continues to run and continues to fill in those caches. If we look back here, so it's got a little bit further now. So it's done 1, 2, 3, 4, 5 of those tables. I think it's working on the next one. And then just give that a moment or two just to finish. Okay, again, just switch back and have a look. There we go. So it must be working on the last one, titles cache. The rest of them seem to be all done. Well, salaries cache is still filling up. Okay. My machine is a little bit slow, and I've got a lot of things running. So there is slight performance hit there, and you know, this is great for just demoing stuff, but in a real environment you would use something slightly more suitable for I think these type of tests and load tests. Production environments. Okay, still filling. I think should nearly be finished soon. As I mentioned earlier, this is a kind of reasonable sized database to work with. It's not, you know, an enormous amount of data, neither is it particularly small, but I think for this type of scenario is very useful to show this. And it's you know, great to run some SQL queries over this type of data as well. Okay, so I think it's up to 1.2 million for salaries, cash 1.3 million. I think it goes to 1.5 million, and that's all the data there. And then there's just one more left. Just give that a moment. There we go. So that one's done, and then it's just doing the last one now. Titles cache. Okay, so the rest are all filled. Okay, let's have a look. Okay, there we go. Let's switch back here. Okay, there we go. So over here, the load caches has completed, and this was our program was connecting as a client. So that's all done. Okay, so the next thing we want to do then is if we switch back here, okay, so all of this is done, and now we have an opportunity to actually run some queries. Okay, so again, if we go to the top here, we've got this queries link and this thing, my Ignite cluster. Okay, so I previously created this notebook and just happened to save these queries. So I've got a couple of these which I've created. So the first one here is just doing a simple select, which is just the key, the first name, the last name, the hire date from the employees table, and then just order by key limit 5. So this is identical to the query that I ran earlier in the terminal directly with MySQL. So if we execute this, here we can see the result just displayed below. And if we compare that to what we had a little bit earlier, okay, so let me just minimize this, and this is the window. Okay, we can kind of see, again, let me just pull this down a little bit, like so. We can see that, in fact, it's the same. The result is identical. Okay. All right, and then another query that we might want to run here, this one is an update. So now this is doing the same thing for this particular key. I was just restoring the data, so let me put in something else here. Let's say Tim is the first name and last name is Smith. Okay, so for the key with the value 10001, we're going to execute this now. Okay, and if we have a look at that, it says updated here. And in fact, if we go back to the top here and rerun this particular query that we had, we can see that, yes, in fact, this has now changed. So the value of that's changed. And again, if we switch back and we go to this, which is our MySQL, and again, let's run the query from MySQL. And again, we notice that the value has changed from Yogi to Tim. Okay, so this is the write-through part. So we were able to read the data, which is okay. We were able to cache that. We were able to run some queries on that, doing some selects. That's fine. But we modified some data, and then we did an update. And then it's not only updated the cache itself, but it's updated what was in the database, as we can see here. And then the last thing we could do, of course, is that we might want to delete something. So in this last query here, delete from employees, where key equals 1001. Again, if we execute this, okay, and it just tells us that, yep, it's done. And if we go back and rerun this particular query at the top here, notice then that the key is gone. We're now 10002 to 6. Okay, and again, switching back to the terminal, if we now run this again from MySQL, we see that that particular the line has gone again. Okay, so again, this is now the first one that we have. Okay, so there you saw pretty much what we were talking about, integration with third party. So let me just switch back to the slides. All right, and you can see that Web Console is actually quite powerful. It allows us to do a lot, and there's a lot in terms of the code generation that's done for us. You saw that there's very little that I had to do. The only thing I had to modify within the code that was generated was just the host and the port number, which I'd already done, and obviously the database name that I wanted to access in terms of the JDBC, and then the credentials, the username and password, which I had to put in so they could connect properly, and then everything else in terms of the being able to load the data, running a node from the IDE as it happens. All of that was auto-generated for me. There's nothing that I had to do as a developer. That was very useful. Okay, so we've done the demo. Now let's quickly discuss Ignite as a memory-centric database then. So we talked earlier about this durable memory, okay? So this idea of being able to persist data and keeping all of that data on disk along with indexes as well, but then letting Ignite manage that for us. So when we want to run a query, it will page the data in if it's not available in memory, and it will use the indexes where necessary as well. Again, that's done behind the scenes for us. No problems there. Some of the other things that it manages for us: predictable memory consumption, automatic defragmentation. So Ignite has its own memory management system as well, which they added, which is very, very useful because being a Java-based system, you know that one of the problems that you have with Java, and which, where it does Java sort of garbage collection, there are sort of things that you can't control very well. And therefore, if you've got large amounts of memory and large amount of garbage collection that needs to be done, the system kind of freezes. I mean, you have to be careful. Some of the other sort of capabilities that they've added, if we look a little bit further, then this notion of a write-ahead log. Okay, so if you're working with the database systems, this is a sort of very familiar concept. So what Ignite does is that as data are updated, it simply appends them to the end of this log, and then sometime later it actually updates the data where it's required. So it does not do in-place updates because that would slow things down tremendously. So this keeps performance tight, and it keeps it, the system very performant. We'll look at that very shortly. Okay, and enabling the Ignite native persistence, very, very simple. Okay, so here is an example. Again, there's a link in the bottom left there to the actual readme.io docs, where it discusses this in more detail and gives examples of this. But it's simply adding a line or two of code. And this is actually quite a lot larger than what I've done in the example that I've got, where I simply added one line to specify that I want persistence. Okay, there's some additional things that we can add here as well, but I've not done that. Okay, so let me show you this demo then. Okay, so again, let's minimize this, and we'll just minimize this. Okay, so we are done with MySQL, so I can exit from here and close this. All right, so what I have in my IDE is another project that I've created. So let me close this one. Okay, so I should properly shut these down. Let's shut down these nodes. There we go. I think it'll be happier now. There we go. All right, so let's have a look at this thing called Ignite World Demo. Okay, and so what this is running some queries across some country data. So we've got some information about different cities in different countries and the sort of population levels. And what we're going to do is from Ignite, we will launch a node. Let's just run one. Okay, just give that a moment. There we go. Okay, I think one should be sufficient. So if we look at the topology here, it tells us servers equals 1, which is fine. That's sufficient for our needs. And then we've got some SQL data processing that we want to do, which is in this particular file. And if we have a look at the code here, you can see there's some SQL code here that we've got. And again, it is reasonably complex. Okay, so there's some joins going on, and there is some order by and group by statements as well, which we saw in the slides a little bit earlier on. Now, what I'll do then from the command line, again, let me try and blow this up just so you can see. Okay, so this is a tool called SQL Line. Okay, so it's a great sort of shell-based tool, allow you to do a range of things, and you know, again, great for sort of working with a bit of SQL code, loading tables, working with tables, and so on. Now, you'll notice here that what we're using is to this we're passing the Ignite thin driver, and I've got a couple of options here. So verbose equals false, show warnings equals false, show nested error equals false. Basically, kill any warnings and error messages for the moment. Otherwise, it just fills up the screen, you know, with sort of a lot of information that I don't need. And then again, we've got localhost setup 127.0.0.1. So let me just launch that. Don't worry about these null pointer exceptions. It's simply because there's a few things that I don't have in the class path, but other than that, this is fine. So I'm in. Okay, so this is a shell-based tool, and again, I've got a script, Ignite World SQL, which creates some tables. It populates them with information about countries, cities, the actual sort of numbers, and we can run this. There we go. This takes a few moments to complete. Okay, just give that a moment. Okay, so that's done. And then if we switch back here, okay, we have this SQL data processing where we're going to run some SQL code and do some analysis and get some results out. So let's run this. Okay, just make this a little bit bigger. So this is now connecting as a client. All right, so the cache, Ignite cache has been loaded with all of that data from the SQL Line tool. And here it's run some SQL code and it's given us some results to look at. Okay, so the first one is the 10 most populated cities in the world. And then the last part here, the 3 most populated cities in the US, Russia, and China. Okay, now, because we've enabled Ignite persistence on this one, okay, this is done through the XML. I showed you the config file in the slides. There's also one other thing that we need, which is this thing here. There's a sort of an extra line of code. I need to do this thing here. Okay, it's this active, this activate the cluster. And it says it's required to do if the persistence store is enabled, because you might need to wait while all the nodes that store a subset of data on this join the cluster. Okay, so this is the kind of the extra bit that I need if I don't want to use Ignite purely as a cache. Okay, so it may take a little bit of time for nodes to come up, but that's okay. Now, the thing is that because I'm using persistence here, this node that I have running at the moment, if I now kill this as such, normally if I'm using Ignite purely as a cache, my data's gone. Okay, my node's gone down, my cluster's gone down, I've lost all my data. But because I'm using persistence, if I restart this particular node, okay, just give that a moment to come up. and go back to this SQL data processing. So let's just clear that and then just run this again. There we are. Okay, so it's run those queries again. So we've got the 10 most populated cities in the world, and then again, 3 most populated cities in the US, Russia, and China. Okay, so there is a work directory, and I think because we are nearly out of time, okay, I'll let you have a look at that. It shows you the write-ahead log, the various partition files that are used to store the data, and there's a lot more information, again, on the documentation that's available on the web. So let's switch back here. Okay, so we've done the demo there. So I think, Alicia, I'll hand back to you. I think there's time for a couple of questions. I'll do my very best to answer them. If there's anything that I can't answer, I'm very happy to follow up. And if anyone would like to contact me directly, it's very easy. It's just first name dot last name at gridgain.com. So that's akmal.chowdhury@gridgain.com. And again, if there's anything that I can't answer, I'll be very happy to chase up my colleagues and ask for their assistance. Okay, over to you, Alicia. Thank you.
Great. Hi. Okay, can you hear me okay?
Yep, I can hear you.
Okay, great. So I'll take as many questions as I can here. I can do a SQL against my cache. He says cache in memory plus native persistent support. But does this work if I do a SQL against the cache in memory and a third-party persistent store like Oracle, MySQL, MongoDB?
Okay. So if my understanding is correct, basically it's combining both of these together. If that's the gist of the question, I don't see why not. I've done these separately. So in the first instance, I connected to MySQL, did a read through, write through, but I didn't use any native persistence from Ignite. And in the second demo, I used the native persistence, but didn't connect to a third party. So I'm guessing that the question is really, is it possible to combine both of these approaches together if I'm working with, say, a third party and I want to use Ignite native persistence? As far as I know, that should be possible. Yes, there's no reason why you couldn't do that.
Okay, next question. What is the difference between cache store support, so read through as well as write behind, compared to persistence capability?
Right. So I think in the first example, you saw that the data are in MySQL. Essentially, that is the persistent store. And so what we're doing with Ignite is simply connecting to that, taking data from this third party, caching it in Ignite. We can run queries in it. We can update data. We can modify. We can do select statements. And then we can push the updates back down into the third-party system. So in that case, there's no, really you're using the power of Ignite there as a cache, the ability to run things at memory speeds, and again, use parallelism, use the power of the cluster. Whereas in the second example, you saw it's a little bit more subtle. So yes, we could use Ignite as a cache, but what we did by enabling persistence, essentially we leave the reading and writing and treating Ignite as a database system itself. There's no third-party persistence there. Ignite manages all of that data for us. It behaves like a database system. And the other thing is that we can work with additional sort of capabilities as well. Things like transactions, for example, that's entirely possible as well. So there, Ignite kind of does everything for us. I mean, that's the thing. But as I said, in the real world, we tend to work with a variety of different systems. So in the first scenario, it's great if you've invested heavily in some existing database system, whether it happens to be MySQL, Postgres, Oracle, or something else, or even a NoSQL system or HDFS. You still can keep that investment and use Ignite's capabilities to enhance what you already have. I think that's the benefit there. In the second instance, maybe you're starting from scratch. You don't have any existing database system to worry about, and you could take advantage of Ignite's sort of persistence capabilities straight away. I hope that answers the question.
Okay, so we have time for one more question. I'm gonna send all your questions that weren't answered over to Akmal
Okay, yes, that'd be
afterwards.
great.
Yeah,
Yeah, yes,
with your
please
email
do.
addresses, so that way you guys can talk directly.
Yeah.
But I think the last question I have, and I tried to, there's been multiple questions from several people, so I'm trying to just go down the list and address one question from everybody as fairly as
Okay.
possible. Okay, so what optimization does Ignite have for 3D X-point memory?
Goodness me. The answer is I don't know, but I can find out. So I will chase that up, and I apologize. But again, it's something. If the questioner would like to contact me directly, I will ask my colleagues within the company, those who are experienced with this technology, and we will get a response to you. I think that's the best I can offer. And I apologize. I don't know the answer offhand.
Okay, well, that brings us to a little bit past the hour. And again, I apologize if I didn't get to your question. As I said, I will get these over to Akmal and he'll get in touch with you. And I will also get everyone a link to both the recording and the slides within 24 hours. So with that said, thank you so much for joining us. Akmal, thank you for doing a great presentation. And we hope to see you on a future show. Thank you again,
Yes,
Akmal.
and I just thank again my thanks to everyone as well, Isha. I appreciate. So for me, it's kind of 8 p.m. So I'm not sure where we are joined by people from all over the world. Perhaps in the morning, evening, afternoon. It could be any time. So again, we appreciate the time that people have given to join us today. Thank you very much.